In the previous video, I showed you an experiment where a brass ring had three tension forces acting on it. We had a 4-Newton tension force acting to the left. Let's call that tension 1. A 6-Newton tension force acting to the left. Let's call that tension 2. And a 10-Newton tension force acting to the right. Let's call that tension 3. Now we want to find some relation between these tension force vectors. And we can look at this right away and say 4 newtons plus 6 newtons equals 10 newtons. How about that? But 4 newtons plus 6 newtons equals 10 newtons is a relation between the magnitudes of the tension forces. It is not a relation between the tension vectors themselves. So I would like us to find a relation between the tension vectors themselves. So why don't you try this, pause the video, and see if you can find an equation that connects together tension vector 1, tension vector 2, and tension vector 3. Not 4, 6, and 10, but the actual vectors themselves. Okay, so here's how we do this. What we're going to do is we're going to take the three tension force vectors and add them together tip to tail. So let's start with tension vector 1. All right, so there's tension vector 1, magnitude 4 newtons pointing to the left. And now let's do tip to tail addition. We'll add on tension vector 2. Okay, so here's tension vector 2. Notice we made a tip to tail addition here. And now we're going to add on tension vector 3, again using a tip to tail addition. So the tail of tension vector 3 is going to go here next to the tip of tension vector 2. And how about that? When you add the three vectors together, tip to tail, the three vectors close on themselves. You end up right where you started. In other words, the vector sum of tension 1, tension 2, and tension 3 is 0. We've arrived here at a conclusion which is actually true, not just for the brass ring in this particular experiment, but which is true for any object which is either not moving at all or moving in a straight line at constant speed. Anytime you have an object which is either not moving or moving in a straight line at constant speed, then the vector sum of all forces acting on the object will be 0. This is called the first condition of equilibrium. The first condition of equilibrium says if an object is not moving or moves in a straight line at constant speed, then the sum of all forces acting on the object is 0. It follows that if an object is not moving or moves in a straight line at constant speed, then the sum of the x components of the forces acting on the object is 0, and the sum of the y components of the forces acting on the object is 0. Okay, so just to be clear, in the sums, here, here, and here, the sums are taken over all forces acting on the object. So in this sum here, this sum here, and this sum here, the sums are taken over all forces acting on the object. So in the next video, we're going to do the first of many example problems where we study an object using the first condition of equilibrium.